Hey everyone, so today's problem of the day is find all distinct subset or subsequent sums. So what the question is saying is that given a set of integers, find all the distinct sum that can be generated from the subsets. So what it means is that suppose we are given the input as 1 and 2. So how many distinct sums we can generate from this nums array? So this is the nums array. So suppose we one case will be we do not take any of them, so one of the sum could be 0. Another case could be we took this 1 and we do not choose this 2, so one of the sums could be 1. Then the next case could be we do not pick 1 and we pick 2 only, so one of the sum could be 2. And the next case could be we pick both 1 and 2, so the next sum could be 3. So this will be our output for this case. The next example is if we take 1, 2 and 3 as the nums array. So in this case, the first case could be we do not pick any of them, so the sum will be 0. One of the case could be we pick one of them, like 1 if we can pick only 1, or maybe we can pick only 2, or maybe we can pick only 3. In that case the sums will be 1, 2 and 3. So similarly we can generate the sums 4, 5 and 6, like 1 and 3 will generate 4, 2 and 3 will generate 5 and 3, and if we pick all of them it will generate the maximum sum, which will be 6. So how to approach this problem? Since the question says we need to find distinct subset, so we should think of a data structure known as set. Why? Because since the sum can be repetitive, because you can see that 2 plus 1 is also 3, and if we choose only 3 then that will also generate the sum as 3. So we want the occurrence of 3 in our answer only once, so we will be using the data structure set, so we do not have duplicates. So this was one thing. Now how we are going to approach this problem? We can solve this problem easily, that because all we need to do is we are having basically just two choices. First is either we can pick an element, or the second choice is we do not pick an element. These are the two choices which we have, and that's all that we need to do. So basically what we are gonna do, suppose our nums array was 1, 2 and 3. Okay, so we can have a variable as sum equals to 0 initially, and then we can iterate through this nums array. Like this is nums array which contains 1, 2 and 3. So suppose we are at this first element, let's say we are here. So we have two choices, we can pick or not pick it. So if we do not pick it, then our sum will remain 0. Then we can go to the next element, then we can again choose not to pick this, then our sum will again be 0. And then we can go to the next element, then we can again choose to pick or not pick. Suppose we do not pick this element, then our sum remains 0. Now when we iterate through the array, that is, suppose if I is the index where we are currently, so if we iterated the whole array completely, then the value of I will become the n means the size of this nums array. So we can just put a condition whenever the our index that we have iterated the whole array I becomes n or greater equal to n, we can just insert whatever sum we got in our set at I equals to n. So that's all that we need to do in this question. So for that, first we will need our data structure set. Let's call this set as sums, because we are gonna store the distinct sums in our set. Okay, and then let's say n is the size of our nums array. So n is our size, and then we can recursively call a function. Let's say the function is solve, in which we can start with ith index. Initially we are saying that I will be 0, and we are gonna iterate it till n, so we can just pass n as an argument. Then we can just pass our set to store the distinct sums, and then we can just pass our array nums. So that's all that we need to do. Now the second thing is how to complete this function, this solve. And what are we going to return in that? Suppose we call this recursive function. What this function will do, we will implement it later, but suppose we have done this solve function, what should we expect? We should expect that our sum set should contain all the distinct sums which are possible. So we can simply, after we have got all the distinct sums in our sum set, we can just return our answer. Because we need to return a vector, so we can just choose create a vector answer, and we can just push every distinct element present in this sum set in our answer. So we can simply write for every element in our sums, we can just push that element in our answer. Sorry, answer, we should push that element in our answer, and after that we can simply return our answer. That's it, that's all we need to do. Now we just need to implement this solve function, that is which will generate which will count all the not count, store all the subsets in our sums set. So let's implement this function. Let it be a void function, void solve. So the first argument which we were taking was the index. So first argument will be int I, the second argument will be the size of our array, int n, the third argument is our set. We will pass it by reference because we want to update the sums in our function call, and we can then pass another our nums array. We will pass this nums array also by its reference, because we do not want the memory to exceed if we pass it by value. So first we need to set the base condition for our recursive call. So as we discussed, the base condition, what will be the base condition? We start from here and we will be ending when our index I becomes n. That is where our recursive call will end. So that becomes our base condition. So what will be our base condition? If I is greater or equal to n, we can simply say, what were we doing when our I is greater or equal to n, that we have iterated all of the array, then whatever the sum we have obtained, initially it was 0, then after iterating, what we will do, we will insert sum in our set at I equals to n. So we can simply just say that insert the sum. Okay, and we forgot to pass sum in our solve function. Initially we decided that the sum should be 0, and then we can simply pass the sum also in our recursive call. So let me mark it here also. So now we have inserted the sum, and we would want to return from this recursive call now. So this becomes our base condition. Now what will be the next thing we need to do in our recursion? Obviously we need to call this. Suppose we are, what are the choices we can do in this recursive call? We need to make a choice here. So we have two choices. The first is we do not pick that element. So if we do not want to pick that element, what will happen? Suppose we do not pick this 0, we will just iterate. We do not pick this, we will just say if the sum was initially 0, then sum will remain 0 and will move on to the next index, to the index 1. So we can simply call our function again for the next index, the I plus 1. The size of array will remain same, and sums set will be passed as it is. Similarly, nums array will be passed as it is, and the sum will remain the same as sum. Why? Because we do not pick the element. And our second choice would be that we pick an element from the current index of the array. So suppose we picked this, sorry, this was the output. Suppose we picked this first element 1. So what we will do, we will just move on to the next index. Size of array will remain same, the sum set will remain same, the nums array will remain same, but now when we move on to the next index, our sum will change. Now our sum will be sum plus this first value which we took, the ith index value. Like it was, if this was I, suppose I is this, then we will take this ith index value of nums in our sum. So we can just say nums I, that's it. So after this, what happened, we have, this is all that we need. We have implemented the whole recursive function, and it is as simple as it looks. So now this is a recursive call, but if we will submit this code now, even though it is correct, we should be getting a TLE, because we can optimize this code by dynamic programming. Why? Because there is overlapping of conditions. Now why is that so? Because let me give you an example. Suppose we remove all this, and I give you an example that let the nums array is something like this: 1, 2, 3, 4 and 5. Right now, suppose there were 2 cases, and let it be 6. Let there be a case when we do not, when we picked 1, we did not pick 2, and we picked 3. Okay, so the sum would have been 4, and I would be here at index 3, right? So what I'm saying is, yeah, so this will be here at index 3. Now there could be another case. Now we will call this function after this index 3, we will call it again for the next index, and then we will complete it till the last index, right? But we can see that sum was 4 here, and after this whatever will be the sums will be done in the next calls. Now suppose there was another scenario where the nums was same, this only, but what we did in this first case, what we did was we picked this 1. Let me mark these elements which we picked. We picked this 1 and we picked this 3 in this first case, and the sum was 4, right? And I was here. Now in the next case, and in this case only, if we do not pick 4, the sum will be, if we move this I to the next element, because now here also sum will be 4, and suppose we do not pick 4, right? Then we move to the next element, then at 5 also, at this 5th index. Now at this index, the current situation is sum is 4, and we have a choice to pick 5 or not. Now let's consider the next scenario, in which what we did, we do not pick 1, we do not pick 2, we do not pick 3, we directly pick 4. Okay, so what will happen? We picked 4 directly and we do not pick any of them, and then we move on to the next index here at I. Now what is the situation here? Again, sum is 4 and we have a choice to pick 5 or not. But now if you see, when we were at the first case, then this recursive call would have already solved this sub problem, and when we are not picking 1 and 3 and we directly pick a 4, then if we just call this function again, we are having an overlapping problem. This problem was already solved before, but we are just increasing a time complexity to solve this problem again. So here we can just use dynamic programming to solve this problem. Like if we can just store these things, that if the sum was 4 at index 4, then we can just store the state that we have already solved this problem, and if this problem is solved, then we do not need to iterate it further. So we just need to, how we can implement this. I know this may be a little bit tricky, so if you are not getting it, you can please rewind the video. So let's now implement this, how we are using dynamic programming. So let's say we need to store these states, so we can just create a dynamic program, DP 2D DP. So here we can just say the size will be n, because that's what we are storing. We are storing in a DP array or DP matrix. DP will store I and the sum value, that is the sum value at this I index. So what will this represent? This represents if we solved this sub problem before or not, right? So okay, now what will be the size of this DP? The ith index can range from 0 to n minus 1, so let the size be n, and the sum can range from 0 to the sum of all the elements, right? So what we can do, we can just take the sum of all elements. For auto element in nums, we can just say sum plus should be equal to element, and here we can just mark this as sum plus 1. Great. Okay, and here we need to make the sum 0 again, because initially when we are calling this function, the sum should be 0 initially, right? So after this, what we need to do, we need to send this DP also in a recursive call, and we need to implement it and modify our code here also, and we need to pass it by reference. And this was a base condition. Here we need to implement one more condition. If now initially this DP array will be filled with 0, what does the DP array represent if it is filled with 0? That we have not solved this problem before. So if DP I comma sum is 1, then that represents we have already solved this problem. If we have already solved this problem, we can simply stop our recursive call here only and return. Now after this thing, if we do not solve this problem, what we are doing, we can pick or not pick, and after this problem will be solved. So we can mark here that DP I of sum At ith index, if the sum is sum, then this problem, if occurs again, we can mark it before only. This we have already solved, so we do not need to increase our time complexity, right? So let's try run this code and see if this is working. It's giving a compilation error, so let's fix this. Okay, we just forgot, there is some mistake in syntax. We just need to write vector int sum plus 1. Okay, let's try run it now. Okay, it's given an error again at line number 19, so we forgot a semicolon. Okay, let's try this again. Again an error at set.insert. Okay, so it is not, its name is sums, not set. Again an error. So what is the error? At line number 41. Okay, we forgot to mark this dp array here, so we need to pass this dp also. So if we compile and run now, I hope there is no error now. Okay, it worked. Let's try submitting the code. Okay, so it is solved successfully, and I hope you like the explanation. If you did not, you can re-watch this video, and if you like the explanation, you can hit the subscribe button and like this video. So thank you, and we will see you next time.